Okay, we're going to talk about bonding basics. Real simple, easy to do if you understand your Lewis dot structures. And so, what I'm going to do is I'm going to do a couple here with you. I think it should be pretty understandable once we get started. So, I'll do them down here in the spaces so we can have some room to do this. Okay, first of all, there's two types of bonds. There's ionic and covalent bonds. Okay, in an ionic bond, atoms are going to transfer from one electron to another. In other words, they're giving them away. And so, what I'm going to do is show you atoms want to have a complete shell. So, if you look at sodium on the periodic table, Na, right, which is 11. It's in column 1. So it actually has one electron in the outer shell. And we have chlorine, which is Cl. Cl. And if you look at chlorine, it's in column 7. So that means it has 7 electrons in the outer shell. 2, 3, 4, 5, 6, 7. And what you can see is that chlorine wants to take 1, sodium wants to get rid of 1. Now, how do you know that? So if you look at the periodic table, everything in column 1, it's easier to get rid of 1 than to gain 7. 2, it's easier to get rid of 2. So that would be boron, aluminum, gallium, indium, titanium. Column 3. Column 3 is a crapshoot. It whether it gains or loses, most often it's going to lose. Column 4 is gain. Column 6, which oxygen, sulfur, selenium, tellurium, polonium, that's going to gain 2. Column 7, fluorine, chlorine, bromine, iodine, astatine, they're going to gain 1. And the last column, which is the noble gases, helium, neon, argon, krypton, xenon, and radon, they don't want to gain anything. They don't want to give anything. They don't want to take anything. So what I'm going to do is show you here real quick kind of what that looks like. So what happens is the sodium says, okay, you can have it. And chlorine then takes the electron from sodium and everybody's happy. Can't really see that color. We'll do it in a neon. Boom. There it is. Now, so what happens though is this. This, because it loses an electron, becomes a little bit more positive, and this one becomes a little bit negative. Right? Why? Because it gained an electron. Electron's a negative charge. Let's do another one. Okay, here we go. Magnesium and iodine. Magnesium. So magnesium is in column 2. M, G. And it has 2 valence electrons. 1, 2. And iodine is in column 7. Now, this is kind of tricky because now all of a sudden you got to do some math. Now, it's not hard math, but I think you'll understand. Iodine only wants 1. So we're going to put an I here, right? And so if we draw out the electrons, 1, 2, 3, 4, 5, 6, 7, and we look at this, we go, aha, okay. Now the magnesium wants to draw or give an electron here. And if that's so, now this one is gone. And if we look, we still have 1 left. And then you go, okay, well, what are we going to do if there's 1 left? Well, it's simple. It finds another iodine. 1, 2, 3, 4, 5, 6, 7. And it then gives that electron to the other iodine, and boom. Now, if you look at all of these now, this magnesium just lost 2 electrons. So it's plus 2. It got 2 times more positive. This is a negative 1. This is a negative 1, which means the I2 is minus 2 combined. So both of those combined is minus 2. And they equal out. Now, again, they're giving them away. So this electron is not with sodium anymore. And this electron and this electron are not with magnesium anymore. Pretty straightforward. Let's go to another one. Let's try another one. Potassium and iodine. Potassium and iodine. So potassium is K. So I'll just do that down here. K. And K is a 1 electron in its valence shell. And iodine is 7. 1, 2, 3, 4, 5, 6, 7. And what happens is it wants to give away this electron. Boom. And it draws. Boom. And now iodine has that. And this is going to go away. It's gone. This would be a little bit more positive, plus 1. This would be minus 1, and pretty good. So another example, sodium and oxygen, Na, Na, and O. Na is 1 in the outer shell, and oxygen is 1, 2, 3, 4, 5, 6 in the outer shell, valence electrons. And you're going, okay, it wants to give this electron away. Makes sense. And we'll show that electron going over there. Boop. But it wants one more, right? So what does it do? It searches for another one, and it has 1 electron in the outer shell. Again, that's how many valence electrons it's in group 1. And it says, thank you very much. And we go boop. 1, 2, 3, 4, 5, 6, 7, 8. That's how many that shell can hold. Now, this is empty. So it goes back to the row before it, and it's happy. So now we have, draw a line, plus 1, plus 1, minus 2, plus 1 and plus 1 equals plus 2. So our actual formula would be Na2O. And this one would be Ki. So that is if it's ionic. Now covalent. In covalent, we're sharing them. In other words, they don't want to give them away. And so how this would look is it says, hey, you can borrow it, but I still want it. So we have in the first one hydrogen and hydrogen. They both have 1 in the outer shell. And it's saying, hey, can I borrow that? Well, yeah, but I want to keep it too. And so what happens is, without letting go, it says, okay, you can share it. You can share it. And the 2 become H2O. 2. And that's how they come together. Now, there's no positive or negative side because they're not taking away from each other. Another one would be hydrogen and oxygen. So hydrogen would be H, and there's one electron in the outer shell. Boop. And oxygen. I guess I changed colors. Oh well. Oxygen. Okay, how many does it have in the outer shell? It has 6 in the outer shell. 1, 2, 3, 4, 5, 6. So it wants 2. It wants 2. Well, guess what? It says, hey, I want 2, but the hydrogen says, well, I want 1 too. I don't want to give it up. And so what does it do? Hold on here. We'll have an H. And we have what's called a double bond, which actually works out pretty cool. So I'll use this one. Boop. And it is borrowing electrons from each other. So they're both giving each other electrons. So it looks like this. So this one is sharing here. They're holding it. This one is sharing here. This one is sharing here. This one is sharing here. So now we go 1, 2, 3, 4, 5, 6. Share 7, share 8. Oxygen's happy. 1, 2. Hydrogen's happy. 1, 2. Hydrogen happy. And we have H2O. That would be written H2O. H2O. And that's how you do it. Pretty simple. So you guys can work on other examples. I'll just stop right there for right now. And that's bonding basics. All right. Give me a second. I'm trying to shut this off.